Designing structures is something I've mastered for the past 10 years, and I've done projects varying from schools, hospitals, arcades, and various structures that some are more tall than others. And today we are going to see a structure I'm doing for one of the schools here in Wakiso that is more than 4 levels, that has a composite slab of waffles and a solid slab. We shall see why you would consider using waffles, their advantages and their disadvantages. Since some of the slabs we have in Uganda range from either waffles, solid slabs, and max span slabs, which can be graded as one-way slab or two-way slabs in design of structures. So today let's see about waffles or a waffle slab that is now composite with a solid slab on this structure that is spanning 8 meters by 11 meters without a center column, and it is going to be functional based on the design. Designing for a waffle slab. So this is how a waffle slab operates or distributes loads. Like we have always said to our clients that there are different types of slabs which have got advantages and disadvantages. Every slab operates and gives its own work or its own ability to transfer loadings based on what a client prefers or what he wants as a finish. There are so many people who prefer max span slabs, others prefer solid slabs, others prefer waffle slabs based on the savings or the focus the client wants, or the person who convinces you to be the winner of another one, because many comparisons have been set up about waffle slabs, max span slabs, and solid slabs. But today we are going to see a slab that has been designed using waffle slabs. For us, we do all of them for our clients based on what the client wants, on what he thinks is an advantage on the other, and we shall share how it operates in engineering. So this is a waffle slab, and we are going to see a slab when it is integrated with a solid slab because of reasons we saw during design. So our waffle slab today we are going to see is here. This is a panel. As we have already said, we have got a larger panel which is from that column to the other column, that is 8 meters, then spanning from here up to there, that is 11 meters, and the client is requesting for the design of a school which has no column, and we have to design it so well so that we don't have a middle column, and does not sag, it does not fail, and it is strong enough to carry over at least 70 students during its purpose or operations. So with the choice of the client, he wanted the waffle slab as his choice. Then we had to integrate in a solid slab to help cater for some deflection forces and make sure that we have a stronger center point which is going to be transferring loadings to different areas. So this is how we had to go about the design. So this is the smaller panel that we designed for the waffle slab. Now what we did, we first designed the entire classroom, which is 8 meters wide by 11 meters wide. Then after that, we had to dissect our classroom into different parts. You can see here we have got a strong beam that is going to be carrying our main loadings to the other direction and this direction. Then we have another strong beam, so divided it into 2 beams. So we have one part here, another part here, then another part here. So because we wanted to make sure that there's no deflection in our beams and we didn't want to put a column there, we introduced a solid slab which is running through the centroid of the class column to ensure that all the loadings that would be brought by the waffles is carried here and delivered to a shear wall that side and also a shear wall here. So at the end of this solid slab we have a shear wall, and the bars that we are passing in that transfer were T16 bars, which we distributed at an interval of 150, because we wanted this solid slab to help as a point that would be carrying these main beams. Because when we would be designing, you'd find that this beam and this one tended to deflect at this point, and they needed supports that could help them in carrying the loadings. So after we had to design the small T-beams. This is a T-beam, as you see it here. This T-beam is going to be helping us to carry a waffle. This is a waffle, as you can see it here. You can carry it, and it is placed between two T-beams. This is one T-beam, this is another T-beam. Our T-beams are we are passing with T12 bars, which are 3. They are here, and they are running a very short distance. That's why we had to pass what we call a secondary beam here, which would be carrying the waffle beam, the T-beam here, that is going to be carrying the waffle. So we design a short panel that is going to be carrying waffles, which waffles are going to transfer these loadings. They come to this beam. This one we call it a secondary beam, purposely to carry the loadings from the waffles. So if you are carrying out design, you are going to first know how much loading is going to be here. Then we see half of this loading is going to this beam, half of this loading is going to this beam. Then you ensure that this beam can carry these loadings from this short panel. They bring them to this beam here. Now, with the solid slab that we provide here, it has got an advantage that for it, if it is distributing its loadings, it is not a one-way slab, it's a two-way slab. It distributes in one direction, the other direction, and this direction, and this direction. So usually on the centroid of a solid, there's less forces during design. So when these loadings come here, now this beam shall have all the loadings that have come to this beam, which is a secondary beam. We have half of it is going on the other beam, then half of it is going to this beam. So you find that half of this loading is going to come on this main beam as a point load. Because the loadings come from this waffle, they all be loaded here, then we design it when it is here. So this beam that is the primary beam, which is very strong, is going to be having two point loads at this point and another point load there that we are going to assess to ensure that it can be able to carry the entire slab. So those strong beams, or the primary beams that are going to help us in spanning this structure or this classroom, are going to be this one here and the other one. Then these panels are going to be having the waffles that we have shown you. So that is how we designed to ensure that this classroom, the way big it is, it can have both an integrated slab of waffles, and also we have a solid here to help support this strong beam, or the primary one that is carrying all the loadings, so that we can have this entire span when it is not having any column. And the structure is able to pass, and we can see it performing its purpose, and there's no deflection, no issues. So that is how waffles operate. So the way they distribute their loadings, this waffle is going to take its loadings to the T-beams, also to the T-beams. The T-beams are going to take their loadings to this secondary beam, which secondary beam is going to have those loadings and transfer them to this primary beam, which primary beam is going to transfer to the other main column, and also here this main column, so that we have got that loading transferred to the ground and the structure is able to be stable. So that is how waffles operate when you are using them in construction. This is a fully spanned structure or classroom that we have designed using a composite slab of waffles and solid slab. You can see it is an 8 meters by 11 meters without any columns in the middle, and it is operational, and it is going to go 5 levels. That's ground plus 4 other levels on top of it. Advantages of waffles is 1, waffles do not take a lot of materials. Remember, they are precast off-site, so you can imagine on this entire line, these are only trees we use when we are carrying out or when we are casting waffles. So you find that you are going to use less materials compared to other modes of slabs. That's why sometimes people like them on projects like schools, hospitals. You can imagine this is a section which is solid, and the amount of trees that are unused which we have are so much compared to the waffles that we are using along here. So waffles use less materials in comparison to these two. Two, they take a very fast time. This slab, the entire surface area, as you have seen when they are casting, is going to be done in 2 to 3 days, which cannot be done with a total max span or solid slab, because the work scope is much of it is done on off-site, and they just come and assemble the waffles on site. So they usually take less time compared to other types of slabs. So if you're using them, that is one of the things you take advantage of. Then it is easier to finish. You just have to smoothen here and paint. No need of finishes and what on top of this. Most of them are used on public structures where there is no need for a lot of finishes. So you find that many people prefer them. At the end of the day, you find you are saving on those other extra expenses for waffles. So those are some of the advantages of waffles as they have been used by many people, those who love them and use them. They also have problems. One of the problems with waffles, you cannot tell the quality of materials used by the manufacturer, since most of the times the person providing with waffles, his goal is to make profits. You might find sometimes glasses are not okay, the strength of the waffle is not fine, the design is not okay. That becomes a problem to you who's going to use. Then another thing that is not good with waffles, they usually have those oval finishes. They sometimes don't look fancy. If you're doing like a hospital, you're doing something that is cool, or you're doing your own home, you end up wanting to cover them and put gypsum, which is more costly. If you use the other slabs, you'd use other methods which are cheaper. So you find that its finish is not all that smooth for some of the structures that are being used. Then another problem with waffles, they need proper design. How they transfer their loadings vis-a-vis the framed structure needs someone who understands proper structures. Some of the people who manufacture waffles, they're in business, but they don't have that expertise designing long-spanning structures. For example, this structure, it has got long beams, so we had to incorporate a lot of design to ensure that we fit the design of the waffles and the client, we balance them. Then lastly, it is workability. Sometimes you have to do thorough finishing to ensure that the waffles come out. You find that they bring waffles, some are break in transportation, some break during casting, and there are those small touches that don't come up so well. So those are some of the disadvantages of waffles. Every slab you ever see being talked about has got advantages and disadvantages. It just changes with someone who's going to use it, what is his purpose of the structure, where are the sources of materials, and that's how they vary based on what you want to use with your slab.